This is the next section. It's on trapezoids. And remember, trapezoids are under the category of quadrilaterals, but they are not parallelograms. Okay, and I'm sorry, this is a little bit blurry, but when I scanned it, this is the best I could do when I scanned it. I'll read through it. A trapezoid is a quadrilateral. Let's see, where am I? Here. It's a quadrilateral. That means it has 4 sides. It's a polygon with 4 sides. And it has exactly one pair, only one pair of parallel sides. For parallelograms, which is what we were doing before, we had 2 pairs of parallel sides. For trapezoids, they only have 1 pair of parallel sides. These are the parallel sides right here. This side is parallel to the bottom side. They're parallel. Only 1 pair. Okay? And that pair of parallel sides, that's called base. So this is called a base, and so is the other side. It's called base. The other 2 sides, which are not parallel, you can see that if I continue this line infinitely and this line infinitely, they will intersect somewhere out in space. So they're not parallel. These non-parallel sides are called legs. So here's one leg and here's the other leg. This is a leg. Okay, so the parallel sides are called base and the non-parallel sides are called legs. And another thing that you need to know about trapezoids is that it has 2 pairs of base angles. So if this is the base, then this is a pair of base angles, and this is another pair of base angles. Okay? So these angles that I've signaled out here, they're called base angles. Okay? Angle A and B are 1 pair, and angle D and C are another pair of base angles. And that's the general definition for a trapezoid. Now we're going to talk about an isosceles trapezoid. An isosceles trapezoid is a trapezoid whose legs are congruent. So remember, in our last slide we were talking about that trapezoids have 1 pair of parallel sides. Here they are. And these parallel sides are called base. And we said that the non-parallel sides were called legs. Here are the legs. For an isosceles trapezoid, the legs are congruent. So that's why you see these tick marks here. That means that this leg measures exactly the same as this leg. That only happens in an isosceles trapezoid, okay? In a normal trapezoid that's not isosceles, the legs are not congruent, okay? Only in isosceles trapezoids. And now another thing about isosceles trapezoids, we have 2 theorems here. It says if a trapezoid is isosceles, then each pair of base angles are congruent. Okay, so only in isosceles trapezoids I can say that the base angles are congruent. That means that this base angle and this base angle measure the same thing, and that this base angle measures the same as this base angle. And that's only for isosceles trapezoids. Okay? Don't be confused. If you see a trapezoid and it's not an isosceles trapezoid, then these angles, these base angles, will not be congruent. Okay? And Theorem 6.13, it says that if a trapezoid has a pair of congruent base angles, then I can conclude that it's isosceles. So 2 ways you have, if you know that it's an isosceles trapezoid, then you can state that the base angles will be congruent with each other. If it doesn't say that it's an isosceles trapezoid, but you know that the base angles are congruent, you can conclude that it is an isosceles trapezoid. Okay? And there you go. Let's see some examples. Here's an example. It says, find an angle measure of trapezoids. PQRS is an isosceles trapezoid. Isosceles. So as soon as I see isosceles trapezoid, automatically I know that the legs are congruent, just like the diagram shows, and I also know that the base angles are congruent. That means that this angle is congruent to Q, and I know that this angle is congruent to this angle. Okay, just because it says isosceles trapezoid. And it says find the missing angle measures. That means I have to find all the other angles. Okay, so I know the measure of angle S is 50 because it's given. Automatically, I know that the measure of angle R is 50 also, because an isosceles trapezoid, the base angles are congruent. Now, how do I find the measure of angle P and the measure of angle Q? Measure of angle P and the measure of angle Q. Now, since this is a quadrilateral, we had said in the beginning that all quadrilaterals, the addition of all the angles inside of a quadrilateral, the measure of angle S plus the measure of angle R plus the measure of angle P plus the measure of angle Q. Let's see if you remember. If I add this angle plus this one plus this one plus this one, what should I get in a quadrilateral? That should be 360. Okay? You should know that. So if I already know that this one is 50 and this one is 50, I already have 100 degrees out of a total of 360 degrees. So 360 degrees minus 100, which I already have, that leaves me with 260 degrees to share between P and Q. Now, how do I share them? Since this is an isosceles trapezoid, I have to share them equally because base angles. For an isosceles trapezoid, base angles are congruent. So that means that this 260, I divide by 2 and I get 130 degrees each. That means this is 130 degrees and this is 130 degrees. So if I add all 4 angles, I should get 360 degrees. Okay? So the measure of angle P is 130 degrees and the measure of angle Q is 130 also, because base angles are congruent when it's an isosceles trapezoid. Another way to figure this out could be just writing out an equation using your algebra. You can write that 50 plus 50 plus the measure of angle P plus the measure of angle Q, all of those have to add to 360. Now I can add these two. This is 100 plus the measure of angle P plus the measure of angle Q equals 360. Now I can subtract 100 from this side of the equation and subtract 100 from this side, and you get 260. This cancels out and you get that the measure of angle P plus the measure of angle Q is 260. Now, very important here, the measure of angle P and the measure of angle Q are equal. So let me write off to the side that I know that the measure of angle P is equal to the measure of angle Q. How do I know? Because it's an isosceles trapezoid, and the definition, the property says that the base angles in an isosceles trapezoid are congruent. So I know that they have to be equal. Knowing that they're equal, I can rewrite this expression and I can substitute the measure of angle P. I can substitute with the measure of angle Q. Okay, so since the measure of angle P is the same thing as the measure of angle Q, I can rewrite this like that. And now I can add these two terms since they are identical. One measure of angle Q plus another measure of angle Q equals 260. I can write that as 2 measures of angle Q equal 260. And then I divide by 2 on both sides. And you get that the measure of angle Q is 130 degrees. So if the measure of angle Q is 130, then this one is also 130 because they are equal. So 2 ways of doing it. You can use whichever way you want. You get the same answer. Here are 3 examples. Finding the missing angle measures. Let's do number 1 very quickly. And it says, notice it's an isosceles trapezoid. Here are my pair of parallel sides. That means that this leg and this leg is congruent because it's isosceles trapezoid. I also know that the base angles are congruent. So this angle is going to be congruent to this one. And this one is congruent to this one. So if I have to find all the angles, I know this is 100, so this one is 100. Already I have 200 degrees, a total of 360 degrees if I add 100 plus 100 plus this one plus this one. That makes 360. So if I already have 200, I can take 360 minus 200 that I've already used, and I have 160 left. Now this 160 I have to share between these two. And I have to share them equally because they are equal. So that means that each one is a half of 160, which is 80 degrees. So this one has to be 80, and this one has to be 80. And if you add all of these up, you should get 360. Let's check. 100 plus 100, 200. 200 plus 80, 280. And 280 plus 80 is 360. You're done. Let's do the next one. Again, these are the legs. Base angles are congruent. This is congruent to that one, and this one is congruent to this one. So that means this measures 70. 70 plus 70 is 140. I have a total of 360, so I'm going to subtract 360 minus 140. That gives you 220, right? Yes. Now I have 220 to share amongst these two angles, which are equal angles. So that means I have to divide 240 evenly into 2, which is 120. So each one of these measures 120. And if you add all of this together, 70 and 70 is 140, 140 and 120 is 260, and 260 plus 120 is 380. There's an error here. Let's check. 0, 2, 2, 220. Oops, here's the error. It's 220. I wrote 240. It's 220 divided by 2, which is 110. So this is 110. I'm sorry about that. That's why it's good to always check, because I can go back and fix. Okay, let's do that again. 70 plus 70 is 140. 140 plus 110 is 250. And 250 plus 110 is 360. Okay, the next one. Notice my pair of parallel lines. These are the legs. They are congruent. That means my base angles are also congruent. So if this one measures 75, this one measures 75. 75 and 75 is 150. So I can take a total of 360 minus 150. and I get 210. That 210 is the one I'm going to share amongst, the top angles, amongst that one and that one. They have to be shared evenly because they're equal. So I take 210 and I divide it into 2 equal parts, so each one gets 105. So this is equal to 105, and this one is equal to 105 degrees. Okay, and there you have it.